So now let's summarize what we have learnt about IBus, DBus and SBus. If the instructions are present in between the memory locations, all right, so then the Cortex processor fetch the instructions using I-code interface. And if the instructions are present outside of this memory location, then processor fetches the instructions the system bus. So similarly, if the data is present in between the memory locations, this one, processor fetches those data over decode bus interface. Also, if the data is present outside this location, then the data will be fetched over the system bus. Okay, so that's the summary of what we have learned now. Now we know that our code is actually stored from this address, isn't it? So does this address fall between these two addresses? Yes, correct, right? So that means our instructions are indeed fetched over the I-code bus interface. Now the read-only data what we have kept is also comes somewhere here, right? So that means our read-only data is fetched over the decode bus. Great, so that's the takeaway from this discussion. So now let's go back to our diagram. Alright, so now let me again open up my reference manual because I want to visit the memory map of the microcontroller. And here you already know that federal region starts from either from 400 or 500. So all these memory locations, if you browse here, they all fall outside this memory regions, isn't it? So that's the reason all the peripherals you saw in this microcontroller will be accessed over system bus. So you cannot use I-code or decode in order to talk to these peripherals. Great, so now let's go back to our diagram here. So that means I-code is already utilized for accessing the flash. The DBus is already used to access data which is stored in the flash. So that is nothing but read-only data. And system bus is used to talk to your SRAMs and all the peripherals. Now the system bus, what you are seeing here, is actually extended over the bus matrix. So this is nothing but a system bus, so which has the capacity to run at the speed of 180 megahertz. So this is a system bus. What you are seeing here is finally it meets a bridge here. And the bridge, what it does is it converts the AHB protocol into APB protocol. So this actually acts like a converter which converts the AHB bus into two APB bus here. And the AHB is actually stands for Advanced High Performance Bus, which runs with high speed actually up to 180 megahertz. But APB on the other hand is slower bus compared to the AHB bus, which will run at the speed of 45 and 90 megahertz in this microcontroller. So the maximum speed of APB2 bus is 90 megahertz, and the maximum speed at which APB1 runs is actually 45 megahertz. So these are actually slower buses, APB. And all these peripherals like timers, UART, SPI, ADC, I2C, so these peripherals are actually hanging to APB bus, not to AHB bus. And the GPIOs are actually hanging on the AHB1 bus. So that means the GPIO has the capacity to run at maximum speed up to 180 megahertz, but that privilege is not given for these peripherals. So these peripherals, you can call it as slow peripherals compared to those peripherals which are connected to AHB1 bus. Okay. And you will also see another high-speed bus called AHB2 bus derived from S-bus interface. Okay. And that is actually connected to some external interfaces like USB and interfacing of camera, because they need actually high speed data transfer. So you cannot connect camera to the APB bus, because some of the video applications, they may suffer because of the low frequency operation of these buses. So now to quickly summarize this, the system bus meets with converter which converts our system bus into two other buses. One is called APB1 and another one is called APB2. And most of the peripherals are connected to APB buses. So hence they are called as slow peripherals. And very few are connected to AHB bus. Those are called high speed peripherals, and our GPIOs are actually hanging to AHB bus. Yeah, that's it. Please go through your microcontroller block diagram and let me know if you face any issues or if you have any doubts. So now let me just take a look into TI's microcontroller, just to see whether these guys follow the same architecture or they do it differently. So in this processor, the Cortex M4 runs at 80 megahertz maximum. And here you can see it also gives out two bus, the decode bus and I-code bus, which is connected to flash. That's exactly same here also. And it also gives one system bus that's connected to a bus matrix. Yes, that's true. S bus connected to a bus matrix. And these are called system peripherals. The system peripherals, you can see here, these peripherals are connected to the APB bus. And some peripherals are connected to AHB bus. And you can see here, the GPIOs are actually connected to both the AHB bus as well as APB bus. So that's the difference. Here the GPIOs are connected only to the AHB bus. So that means you can operate GPIO as a high speed peripheral, or you can operate it as a low speed peripheral. Yes, you can see here most of the peripherals are actually connected to a PB bus, just like this design. Okay, here also most of the peripherals you will find hanging to a PB bus. And system bus is also connected to a SRAM here, and here also it is same. Okay, system bus is actually it connects over bus matrix to the SRAM, so exactly same as here. Great guys, that means these two microcontrollers follow almost same design, and you can check with your microcontroller. You should also see something similar. Great, so now that's the end of this lecture, that is microcontroller bus interfaces. Great, I'll see you in the next lecture.